Welcome to Physics World Online College for simplified physics and for you to pass your exam in flying colors. Please subscribe if you have not done so and share this class video with your friends in Facebook, WhatsApp, TikTok and other social media handles. In our class for today, we will continue with our discussion on friction. Here we want to elaborate on the two types of friction: static or limiting friction and dynamic or kinetic or sliding friction. I want to use a calculation to differentiate clearly between both of them. In our last class, we said that static friction is the force that needs to be applied or the force that needs to be overcome for the object to just start to move. So anytime you hear just start to move or just start to slide, you know that the frictional force that is discussed there is static or limiting friction. While the force that must be applied or the force that must be overcome for the object to move with uniform speed or velocity is the dynamic or kinetic or sliding friction. So in dynamic or sliding friction, we are going to talk about the acceleration of the body, and we're going to talk about the resultant force that produces the acceleration or the motion of the body. So I want you to take note of that. Let me recap using some of the formula we established in the last class. We said that the frictional force applied on a body is directly proportional to the normal reaction or normal force. And we say if you remove the proportional sign, you will have frictional force to be equal to coefficient of static friction times the normal reaction. And we said if the body is on a horizontal surface or plane surface, then the reaction will be equal to the weight of the body and is equal to mass times acceleration due to gravity. This G here is acceleration due to gravity, not gram as a unit of mass. Good. Then we also said that if you make coefficient of friction the sort of formula here, you will have that coefficient of friction is frictional force over normal reaction. We call this equation 1, this equation 2, and this equation 3. So I'm continuing from here. I said for static friction, equation 3 can be written as, or equation 3 becomes coefficient of static friction and the force here becomes static friction or static frictional force to be divided by the normal reaction. So I'm going to, for sake of simplicity, retain this initial for static frictions, which means here now either to refer to as coefficient of friction is now used as coefficient of static frictional force. Like I said, that is the first friction that you will need to apply before the body will start to move. So here I'm still retaining this symbol for static frictional force. When the body just start to move, the force you need to apply, then here is normal reaction. So what am I saying? If in the question as we have here, they say find the coefficient of static frictional force, I'm still going to use this letter to represent coefficient of static frictional force, which I've used generally as coefficient of friction here, just for simplicity of the calculations. Then I am also retaining this initial for static frictional force. I hope you understand what I'm saying. I will still say more about that. Okay, so this is still similar to our equation 3, as we said, because I didn't make changes. So I'm using this general equation for coefficient of friction as also to mean for coefficient of static friction. That's the point I'm making. Then, if it is for dynamic or kinetic friction or sliding friction, then I'm going to use this initial. A coefficient of kinetic friction, is equal to kinetic frictional force. You see that kinetic frictional force divided by the normal reaction. Okay, so at the initial here now for coefficient of kinetic friction, I will use mu k for kinetic. This frictional force, coefficient of kinetic friction or dynamic friction divided by the normal reaction. So I call this equation 4. Now there's something I want to say here. This kinetic frictional force is usually the resultant force that produces the motion or produces the acceleration. So I want you to note that kinetic frictional force is the same as the resultant force. Kinetic frictional force is equal to the resultant or net force. That produces the motion. So what am I saying? I'm saying Fk is equals to F net. If you don't say F net, we'll say F resultant. Now, I will talk about it shortly. So what am I saying? That in questions where they want us to determine the coefficient of kinetic friction, you will use a kinetic frictional force, which is the force in that system, divided by the normal reaction in the system. That is what I'm saying. Then if you are looking for the coefficient of static frictional force, you will use the static frictional force divided by the normal reaction. So let's look at a particular example, as we have the example 2, solution to example 2. Or let me explain further about this dynamic friction. Okay, no problem. Let's look at solution to example 2. I will explain further about this dynamic friction in the second example. So we have the body, and the mass is given to us as 5 kg. So it's on a horizontal platform that has frictional force, so it is rough. Now the weight of the body will act downwards, which I said is equal to mass times acceleration due to gravity, and the weight is balanced by the reaction. So the reaction is equal to the weight, which is also mg. So that gives you what? M is 5, G is 10. That gives you 50 Newton. The force applied is going this direction, then the friction will oppose it by going this direction. Now, in the question, we are given the force applied as 20 Newton. Now, I said, once the force applied is given, at the point where the object just starts to move, which is for static frictional force, then this force applied will be equal to the frictional force. So I want you to take note of that. So I said, at the point where the body just starts to move, the force applied becomes equal to the frictional force. So you see the way it translates the frictional force. I'm now saying that force applied, which is Fa, is also equal to the frictional force, which is Fr. Now, since force applied is 20, then frictional force is also what? 20 Newton. So both of them are equal. That is a static friction, which means if you are giving the force applied a static friction, it is the same thing as the frictional force. If you are giving the frictional force a static friction, it's the same thing as the force applied. That is the point I'm emphasizing here. So, which means if we want to now get the coefficient of friction, which we are asked to look for in this question, we will quote the formula now. Equation 3. So we say from equation 3, the coefficient of static friction, because that's what the question says, find the coefficient of static friction. The coefficient of static friction is frictional force, static frictional force now, over normal reaction. Good. So I will substitute. Always state your formula before you substitute. And when you are substituting, please don't go with unit. In substitution, you put only the values. After getting the answer, you apply unit if there is unit for the quantity. So the frictional force is 20. The normal reaction is what? Is 50. So I divide 20 by 50. I will get 0.4. No unit, because coefficient of friction is what? A ratio. It does not have unit. It is dimensionless. So the answer to this question now is 0.4. You understand what I've said here? This is the key point to this information. So in questions where frictional force is given and it's a static friction, that frictional force is equal to the force applied. Likewise, when the force applied is given, then the frictional force is equal to that force at static friction, where the object just starts to move. Now, let's talk about what it will be at dynamic or kinetic friction. So let me tell you what difference will occur if this body decide to what? To move with an acceleration. Then what will happen? That is the point we want to establish. That one is at dynamic or kinetic friction. So let's look at example 3. I will use it to explain it. The solution to example 3. Now we have the body. Observe the way I'm going to do this. We have the body with mass given to us as 40 kg. So which means the weight will add downwards, which is mg. Now this weight is equal to the reaction, which is also mg. So which is equal to 40 g is 10 times 10, giving you what? 400 Newton. So the reaction is 400 Newton. Now the force applied, we don't know it. They want us to look for it. The frictional force, we will also determine the frictional force because we are given the frictional force. And then here, this body has what? An acceleration. So calculate the force that required to accelerate the body. It has what? Acceleration of 3.5 meter per second square. 3.5 meter per second square. Or let me use 4. I have acceleration of 4 meter per second square. Now, so for this object to move, I'm explaining the dynamic friction now. For this object to move, it means the force applied has to be greater than the frictional force. And if the force applied is greater than the frictional force, then the object will move in this direction, in the direction of the applied force. In that case, these two forces now will not be equal again at dynamic friction. These two forces will not be equal, as we said here. Here at static friction, they are equal, but at dynamic friction, where there is acceleration, the force applied is greater than the frictional force. So to get the resultant force, we will subtract. We will have force applied minus frictional force. That is now going to give us the resultant force that produces the motion. Good. So I wanted to do it in a step-by-step. Let me infuse this static inside of this dynamic so that it will make more sense. So see the way I'm going to do that. We have the body, there's the acceleration. So I said the motion will go this way. So let me put the acceleration here. Look at what I did. Arrow, I put A is 4 meters per second square as given. Now, why did I put the arrow this way? Because the force applied is going to be greater than the frictional force. So that is why the acceleration will go this way. So look at the step I will take. First of all, we determine the reaction, which I've said is 400 Newton. Next, I'm going to determine a static friction. A static friction, I said the force applied will be equal to the what? The frictional force at static friction, which means the coefficient of friction is given in the question as 0.5. So mu is given as coefficient of friction is given as 0.5. Now, I will now have to use it with the reaction to get this frictional force. So here, frictional force is equals to, this frictional force now is static frictional force. Is coefficient of static friction multiplied by what? The normal reaction. That is giving me as 0.5 times the normal reaction, which is what? 400. That will give us 200 Newton. Do you understand what I'm saying? I have to determine the frictional force. Take note, I'm using this formula to obtain the frictional force, static frictional force, when the object just starts to move. I get that frictional force. Next, I will get the resultant force that will produce the motion. The resultant force that will produce the motion, as I said, is given as the resultant force that produces the motion is given by F resultant equals to mass times what? Acceleration. This formula is obtained from the formula of force. We know that force is mass times acceleration. So here, this resultant force, like I said in this point, is also equals to the what? Kinetic frictional force. That is what produces the motion. Is given by ma. So that will be given as m, that's the mass, is 40. A is 4. That will give us what? 160 Newton. Now, this resultant force, which we have calculated as ma, I said, is also equal to the applied force minus the what? Frictional force. So I said also force, the resultant force is equal to the force applied minus the frictional force. The force applied minus the what? Frictional force. I know the resultant force. I know the what? Frictional force, which means the force applied can be what? Obtained. Good. So therefore, the force required to accelerate the body is given by I'm going to make what? The force applied, which is Fa, the Tvet1 formula. If you do that, you will carry this frictional force to this side. The minus changes to plus. So which means the force applied is the resultant force plus the frictional force. Plus the frictional force. So since I know the two forces already, I know the resultant force 160, I know the frictional force 200, so I will add the two of them to give me the force applied, which is what? 160 plus 200, giving you what? 360 Newton. This is the what? Force required to make the object to what? Accelerate. And that's your answer. Now, I want to take these two formulas and join them together and give you just a single formula which you can use, of course, to solve this assignment that we have. Now, what I'm saying in essence is, note that as dynamic friction or kinetic friction, the force applied must be greater than the what? The frictional force, so that the net or resultant force will produce the motion. Is that clear? And the formula to obtain that, joining this equation, this one and this together, will give me force applied minus the frictional force is equals to the net force. Now, in this question, I'm looking for frictional, the force applied. I make Fa the Tvet1 formula, I carry this here and add. That is what I have done. In this question, they ask you for the what? They ask you for the acceleration. So here, you are going to make what? A, acceleration, the subject of formula. You are given the frictional force. You are given the force applied. Okay, what is the acceleration given to the steel rod? You are given the force applied. You are given the frictional force. So you make A the Tvet1 formula to get this. Then in this one, they ask you for the coefficient of friction. So this formula, I can write it as this, or force applied minus, in place of frictional force now, I put coefficient of friction, normal reaction, equals to what? This also formula we also serve. So in this case now, in questions where we are now looking for the coefficient of friction, this coefficient of friction here is a what? Coefficient of static frictional force. That is why I retain this symbol for static frictional force. You make this coefficient of static friction the Tvet1 formula in this assignment number 2, and you will obtain it. I hope you understand what I'm saying now. So this formula are the two formulas you will need for this dynamic friction calculation. Then in the last point, if you are asked to now determine the coefficient of dynamic or kinetic friction, then you will now use this coefficient of dynamic friction. This one is of static, like I've told you. It will be the what? The resultant force divided by the normal reaction. So if you have any question where they ask you the dynamic friction, to look for it, then you will use this. I hope the points are noted. I expect you to do this assignment and submit to me. I will look at it. See you in the next class. Bye.